Hi everyone. We're going to talk about distance today. And I'm going to start with distance in just one single direction, meaning like forwards or backwards on a number line. Now, one way to find distance is by just taking any two numbers and subtracting them. So for example, if you're dealing with two positive numbers and you do the bigger one minus the smaller one, it's a real simple concept. If I said on the number line, what's the difference between 4 and 7, and you did 7 minus 4, you get 3. Those numbers are 3 spaces apart. Very, very simple. Now, if I just take kind of two random numbers and subtract them, though, without ordering them, what if you did the smaller one minus the bigger one? So you go 4 minus 7, and you get negative 3. Now, see, we don't want distance to be negative. We don't want to say, oh, how far apart are these numbers? They're negative 3 spaces apart. It doesn't really make sense. They're 3 spaces apart. And that's why, you may remember this from when we talked about absolute value way back early in first semester. We use absolute value to represent distance. So let's say I have 2 points, A and B. We don't know which is the bigger one. We don't know which is the smaller one, just kind of two generic points, A and B. If I want to know the distance between them on a number line, what I do is the absolute value of A minus B, or B minus A, it doesn't matter. Just subtract the two. And the reason is absolute value is going to turn it positive anyways. So let's say we use the 7 and the 4 again. If I do absolute value of 7 minus 4, the 7 minus 4 is 3, and the absolute value of 3 is 3, because it's already positive, you leave it. But with the absolute value, if I had the numbers flipped, and I did 4 minus 7, well, 4 minus 7 is negative 3, but remember, absolute value turns everything positive. The absolute value of negative 3 is 3. So if we say the distance, to find the distance between 2 points on a number line, subtract them in any order, doesn't matter, and then just make it positive, absolute value. Now, if you're actually looking at the number line, the easier way to do it is just count spaces. Just say I'm starting here at how far apart are they? 1, 2, 3, 4, 5 spaces apart. So the whole thing about absolute value and subtracting, that's more of an abstract concept if you just have the two numbers and you want to find their distance. But if you have a question like this one here, the easiest way is just count spaces. So the question is, we're going to go to congruent line segments. So remember, a line segment would be like from point A to point B, line segment AB. And congruent means equal or the same. So if I look at some of these, like the distance from A to B, I wouldn't subtract. I would just count squares. From A to B, 1, 2, 3. I'm going over 1, 2, 3 squares. So the distance from A to B is 3. The distance from B to C is 1. And the distance from C to D is 1, 2, 3 again. So right off the bat, I can say that line segment AB is congruent to line segment CD, because they're both 3 units long, and if they're the same length, they're congruent, they're equal. Now, there's actually one more answer to this question, though, that you might not have seen. It's almost like a trick answer. Because when you look at it, I only see, like, the first thing you see is those the three line segments, AB, BC, and CD. But AC is 1, 2, 3, 4 squares across. And so is BD. If I start from B and go all the way to D, it's 1, 2, 3, 4 squares. So there's a second answer here. AC is also congruent to BD. So make sure you're checking all the line segments and you're just telling which ones are the same length. So we had 2 of them, the first 2. The length of each of these line segments is 3, A, B, and C, D. And for the second one, the length was 4, but they're still congruent, they're still equal. Okay. So back to distance. Let's talk about not distance on a number line, but distance in a coordinate plane. So all of a sudden you have both x and y. So let's say we have 2 points in a coordinate plane. We're going to number them like we did when we were talking about slope. x1, y1 is the first point. x2, y2 is the second point. And we can find the distance between those 2 points using what's called the distance formula. Now the distance formula, it's a little bit longer, it's messier, it looks maybe harder. It's not really harder, it's just a little bit more complex, there's more to it. But here's the distance formula. Capital D for distance is, and the whole thing is one big square root, and then inside the square root you have x2 minus x1 squared plus y2 minus y1 squared. So you're taking the x's, you're subtracting those and squaring it, taking the y's, subtracting those and squaring it, add it all up, and then once you add it all up, you take the square root of your answer. So let's try one of those out. Let's find the distance between these 2 points here, 5 comma negative 3 and negative 1 comma 4. So remember, every point is xy. So like this point, 5, negative 3, the 5 is the x and the negative 3 is the y. Now, since we're using more than one point, we want to number them. So let's make this our x1 and our y1. And then on the second point, this is the x and this is the y, but we'll make this the x2 and the y2. Now the distance formula, which I just gave you, big square root, and it's x2 minus x1 squared plus y2 minus y1 squared. Subtract the x's and square it, subtract the y's and square it. So let's put the numbers in. x2 is negative 1, minus x1 is 5, and then we'll square that, plus y2 is 4, minus y1 is negative 3, and we'll square that. Now remember your order of operations, those two sets of parentheses have to come first. Negative 1 minus 5 is negative 6, we'll leave the squared for now. Minus a negative 3 is going to turn into plus a positive, so you get 4 plus 3, which is 7. After parentheses comes exponents. Negative 6 squared. Now remember, negative times negative is positive. In fact, anytime you square anything, it's always positive. So negative 6 squared means negative 6 times negative 6, and it's positive 36. Plus 7 squared. 7 times 7 is 49. Add those two things together. Let's see, we get 70, we get 85. And that's basically the answer. We can use a calculator to get an approximation for it. You can type it into a calculator, it'd be a little bit more than 1, probably like a little bit more than 9, sorry. 9 squared is 81. So 85 is a little bit more than that, maybe 9.2 or something. But this is fine for an answer for now. We'll work more on square roots later on what to do with them. For now, we just want to work on getting that answer. But that's the distance formula. It's kind of messy looking. You're welcome to use a calculator for it, that's fine. But it's that big square root, x2 minus x1 squared plus y2 minus y1 squared. And then make sure you follow order of operations. Parentheses first, exponent second. There was no multiplication or division, addition last.